This is 5.1, simplifying trig expressions. So we're going to go ahead and start, and above us we have the odd identities, the even identities, reciprocal functions, quotients, and the new ones are the Pythagorean theorem identities. So just to be aware, all of these here, you must absolutely memorize all of them. And also know, along with these, we also can manipulate them and get used to seeing them in all of the other fashions. So what I mean by that, if I take that first one, sine squared plus cosine squared is equal to 1. Also, just as common, be prepared to understand that that has two other ones. I can also say that the cosine squared of theta is equal to 1 minus the sine squared of theta. Or I could say that the sine squared of theta is equal to 1 minus the cosine squared of theta. All right, so before we start manipulating these and simplifying them, there's a couple of things that are really different from what we've used before. So let's just first talk about what sine squared of theta is equal to. That is equal to sine of theta times sine of theta. Now, when I'm saying this and doing this, understand that this theta, whatever it is, must always be exactly the same. Now, one of the really common things that I see in as far as an error goes is this. Sine of theta squared is not and never the same thing as sine of squared theta. All right, this first one piece here means the argument on the inside is being squared, where sine of theta, as I said before, this piece here means that it's the sine function times itself. All right, another thing that we have to worry about when we're doing operations with theta that is a little bit different from what you're used to and different from, let's say, polynomials. If I have the sine, let me change that back to white. If I have the sine of x times the sine of y, there's nothing you can be done with this. These are two different terms. You cannot combine these. And again, that's because that this argument here is different from this argument there. When that happens, there's nothing you can do. This would be as much as you would be able to simplify that. The same thing goes in reverse. If I go ahead and I have the cosine of alpha plus beta, you cannot separate those two functions. We do have an identity that we can use to separate those functions, but that will be in 5.2. All right, so let's go on to a couple other operations with this that are really important. And again, these are just things that you cannot do. This is this, if I have the sine of x over x, again, cannot simplify or cancel. You cannot do anything with this. It has to say sine of x over sine of x. Remember, sine of x is an entire piece. Think about this somewhat similar as to if you had x plus 1 over x, where that x plus 1 is in parentheses and you can't cancel. Same idea with this one here. All right, there's only a few more rules that we have with this. Just want to go make sure I go over all the different pieces. If I have x times the tangent of x. Again, this is one different piece. There's no way to distribute this. This side, this argument of x is the tangent of x. This is x all by itself. There's nothing to be done. You cannot combine the x's. Now, there is one way that you can go through and combine. Let's say I had three times the tangent of x times 2 times the tangent of x. Now, the tangent of x is here. This is another of tangent of x. Because you are multiplying the tangent of x by exactly the same thing, and the key here is, again, that what has to be inside here is this, and this have to be exactly the same thing, including that variable there. Then I can go ahead and equal to say that would be 6 times the tangent of x. Think of that as squared, which means that is 6 times the tangent squared of x. All right, so again, one more example with this. If I had 4 times the sine of 3x, nothing you can do with that. You just have to leave it. If I had the secant of x times the secant of 2x, because these two arguments are different, there's nothing you can do. This is nothing you can right now. We'll do identities for double angles, but right now you cannot combine them because what is inside here is different.